All right, hi, it's Miss Robinson. So today we're going to be talking about chemical reactions, and you're going to be taking these notes in your notebook. So make sure you're listening and you're taking very thorough and good notes. Okay. All right. So we're already gone and talked about physical chemical changes yesterday with Miss Gephardt, and so now that you know something about physical changes, this is something that is not, we know that physical change is something that is not permanent. A chemical change is something that is permanent and it becomes a new substance, and that will produce a chemical reaction. So a chemical reaction is a change, and it is going to show that we've got a new substance, okay? It's a new substance, and is being produced by changing the arrangement of the atoms, okay? So that's telling us that the change occurred between the bonds of the atoms, and then them being broken, and the new ones are going to be formed. And that's why it's a chemical change. It's from different atoms, because basically the atoms, and we're broken all the bonds, and it's rearranging them in different ways so that that's causing a chemical reaction. Okay. So, and a reactant. So, a reactant, is the stuff that we start off with. So, if you have vinegar, and then we have baking soda, and those are the two things that I have, right? And they're both reactants. They're both going to start at the beginning of a reaction, and then I mix these together. So, there are things at the beginning of a chemical reaction. So, and these mix together to create a product. And so, if we have baking soda and vinegar, okay, and we pour all of it in the baking soda into the vinegar, I'm going to get all this bubbling action, lots of bubbles, lots of fizzing that's going on, and that's going to be the product being produced. So, is the chemical reaction being produced, and you're going to get two reactants basically coming together. So we will look at the chemical equation. All right, we're right here, which is what you see here. These are the reactants, and these are the products. All right, so this is the stuff that is in the beginning, okay, and so that we just talked about. So that's the stuff over here, okay. So this means that methane here, so this is the methane, and we have oxygen here, okay. If we put methane and oxygen together, I'm going to get carbon dioxide, and I'm going to get a little bit of water, okay. So those are the products. So we have the reactants we start with, and we end and we finish with the products, okay. So a chemical reaction, so there are four ways to know that a chemical reaction is occurring. So the first way is a color change. And now I want you to think of a color change if it's when you're adding food coloring to water. That is not a chemical change. That's a physical change because it's still water. And it's just whatever color you made it, blue, green, purple, orange, red, whatever color it is, it's still water. So a color change in a chemical reaction means you have mixed two different things or substances together, and you have a sudden change occurring, okay, and it's something new. Okay, so if we look at this nail, so we look at the nails, and you put in the element, that iron in that nail is going to turn brown. It's going to basically rust, and the product is brown because that change is occurring. All right, so if you take two very clear substances and you mix them together, and then it will turn the cup pink. That's what I mean by a color change. Okay. All right. So the second thing is the formation of a precipitate. Okay. A precipitate is a solid. It is a solid product when liquids react. Okay, so for example, in 6th grade, remember we did the milk and the Red Bull, and we mixed those two liquids together, and it basically made a solid like so and like so in that test tube. All right, so with those two liquids added together and they became a solid. So that's what basically a precipitate is. Okay, so the third chemical reaction is a temperature change. Okay, it's a temperature change, and you basically see that with the flame or a warmth filling. So if we know water, if it boils and then it evaporates, yeah, we know that's gas. But you're taking this liquid and this solid and you're mixing it together, and then that starts to boil. That is like baking soda and the vinegar mixing together. You get the bubbling action. That's a formation of a gas, okay? And last but not least, we have a okay, so last but not least, temperature change. Do we skip one? Yeah, temperature change. Sorry. You can see in the beaker here how it gradually, sorry, in a beaker it will gradually get warmer, and when you mix those two substances together, the temperature can obviously change as well. But now we have an exothermic reaction. I want you to remember with exothermic, exit, that is basically the energy being released. Okay, it's exiting. The energy is being released and exiting. So, and with that heat, for example. Okay, when we're talking about endothermic, same thing, opposite. Endo, in, even though it's an en, but that's when the energy is being absorbed and not being released. Okay, so you would probably detect it getting cooler. Okay. So 3 factors that affect a reaction rate. So how quickly a reaction goes. Baking soda and vinegar. What things affect how quickly the reaction happens? And the first is concentration. We know basically when you mix baking soda and vinegar, that concentration is how concentrated that vinegar is and how much baking soda you put in there. Then you have your surface area, and that is how is where you put the products in. So if you use a small beaker or a large beaker, something that you're working with. And the third thing is that temperature. That is basically, are you at room temperature? Are you heating this up? Are you going to freeze it later? Basically, how quickly that reaction occurs. Okay. And finally, we have our catalyst. Our catalyst basically will increase the rate of the chemical reaction, but it's self-consumed, but not it's self-consumed in the reaction. So this is basically means if you have, when you're eating, you're spitting your saliva, that's your catalyst. So when you're chewing your food and it starts to break down the enzymes in your saliva, it's helping it to get wet and moist. And when you quickly eat it, it dissolves, and then you can swallow it. And then it goes down to your tummy, and your stomach does the same thing again, and it's speeding up that reaction. Okay. Make sure you took thorough notes. If you have any questions, please let me know. I know this is a quick video. It's basically a review from what we talked about in 6th grade, and also it's more in depth. Once you finish your notes, make sure you take the video notes quiz, and I will post the code on the board, and then we'll begin our chemical reaction indicator lab.